Topic is a half-wave rectifier with shunt capacitor filter. Half-wave rectifier with shunt capacitor filter. Why the name came as shunt capacitor filter? ఎందుకు వచ్చిందమ్మా నేమ్ షంట్ కెపాసిటర్ ఫిల్టర్ అని?
Capacitor is parallel to load resistance.
Yes, it is my half-wave rectifier. And here I am using a filter component as a capacitor. Here I am using filter component as a capacitor. It is my diode. It is load resistance. Our filter component capacitor is connected in parallel to the load resistance. That's why here we will call it as a shunt capacitor filter. Here we are using a filter component as a capacitor, and this capacitor is connected in parallel to the load resistance. That's why the name came as half-wave rectifier with shunt capacitor filter. Now I will draw the output waveform of a half-wave rectifier. All of you know that it is a half-wave rectifier output waveform of a half-wave rectifier without filter. And here I am using a shunt capacitor. So because of capacitor, I got the capacitor. All of you know that capacitor charges and discharges. So it is a output waveform. When we are using a capacitor filter, it charges and discharges. So it is our output waveform of a half-wave rectifier with filter. It is our output waveform without filter. And it is an output waveform with filter. Similarly, it is having the same without filter is having a equation 0 to 2 pi. It is sin omega t. From pi to 2 pi, it is a 0. For with filter, we have an equation that I is equal to with filter. Equation for this red line waveform is I equal to IDC plus 2IDC into cos omega t plus 2IDC into cos 2 omega t plus 2IDC into cos 3 omega t plus so on. It is a output equation of a half-wave rectifier with capacitor filter. Half-wave rectifier with capacitor filter. In this output equation, how many DC components are there?
One, sir.
Yes, one. Constant value అనేది DC అమ్మ. ఇక్కడ cos sin వచ్చిందంటే ఇవన్నీ AC components. ఓకే, కాన్స్టెంట్ ఏదైతే ఉందో అదే DC component. All of you know that gamma can be written as ripple factor can be written as VAC by VDC or IAC by IDC. So here what is it is a DC component IDC. IDC ఒకటే DC component. So I can write what is the equation for VDC is a IDC into only DC component is ఒకటే ఉంది కాబట్టి IDC DC current component is a I is equal to IDC. So VDC can be calculated as IDC into RN. For DC component, DC ki capacitor is acting like a DC. For DC values, capacitor is acting like a XC equal to 1 by 2 by FC kadamma. What is the frequency of a DC component?
Infinity.
Yes, infinity. So it is acting like a open circuit. For that's why we will not consider for DC value calculation. We will not consider capacitive reactance. Only VDC can be written as IDC into RN. So here we have so many AC components. We can calculate here VDC ఉంది కాబట్టి VAC calculate చేసాం అనుకోండి. Similar to the IAC, మనకి ఎక్కువ ఏసీ కాంపోనెంట్స్ ఉంటే ఓవరాల్ ఏసీ కాంపోనెంట్ ఎలా క్యాలిక్యులేట్ చేస్తామో ముందు చెప్పాను. VRMS1 స్క్వేర్ ప్లస్ VRMS2 స్క్వేర్ ప్లస్ VRMS3 స్క్వేర్ ప్లస్ సో ఆన్. ఇక్కడ మనకి చిన్న చిన్న టర్మ్స్ ఉన్నాయి కాబట్టి 3 క్యాలిక్యులేట్ చేద్దాం. VRMS1, VRMS2, VRMS3. Okay, so how I will find a VRMS1? What is a IRMS1? Let us consider it is my first AC component. Okay, how I will find the RMS value of a current? మనకి IM sin omega t ఉందనుకున్నాం. RMS value, what is the RMS value of this signal?
IM by
Yes, IM by root 2. Similarly, what is the maximum value here?
2 IDC.
Yes, 2 IDC. So what is the RMS value of this signal? Maximum value is a 2 IDC. IM value is a 2 IDC. Yes, so I will find RMS component values. RMS current is nothing but a 2 IDC by root 2. So 2 IDC by root 2 into, when we are finding a RMS value, means AC value, we have to consider both C as well as load resistance. But here C, we can neglect RL value compared to the C value. So I can write only 1 by omega C. Direct magnitude rasanama 1 by omega C rasanama. It is a IRMS value. All of you know that VRMS can be calculated as IRMS into resistance value. Here we have a two resistances, C resistance of a capacitance, which is a capacitive reactance, and resistance value. Compared to C, we can neglect resistance value. That's why I neglected this value. I have written IRMS into this resistance as 1 by omega C. Similarly, any one of you can tell what is a VRMS2 value? From this, what is a IRMS2 value?
2 IDC.
Yes, 2 IDC by
root 2 into 1 by omega C.
Here, what is in place of omega? See here, what is? Yes, exactly, 1 by 2 omega C. Similarly, what is a VRMS3 value? ఇది సింపుల్ గా ఉన్నాయి కాబట్టి 3 RMS కాంపోనెంట్స్ కన్సిడర్ చేసుకున్నాం. మీరు ఓన్లీ 2 కన్సిడర్ చేసుకొని క్యాలిక్యులేట్ చేసినా పర్లేదు. సో వాట్ ఈస్ ద VRMS3 వాల్యూ? 2 IDC by
root 2 into 1 by 3 omega C.
Yes, exactly, 1 by 3 omega C. So it is a VRMS1, it is a VRMS2, and it is a VRMS3. Now I have to find the overall AC component. I want to find the overall AC component. All of you know that VAC can be written as root over VRMS1 square plus VRMS2 square plus VRMS3 square. So what is the VRMS1 value? Here I got 2 IDC by root 2 into 1 by omega C. So sorry. Here I got VRMS1 as 2 IDC by root 2 into 1 by omega C whole square. Okay, plus రెండోది ఏమొచ్చిందమ్మా 2 IDC by root 2 into 1 by 2 omega C వచ్చింది. VRMS2, see here, VRMS2 is 2 IDC by root 2 into 1 by 2 omega C. VRMS3 is 2 IDC by root 2 into 1 by 3 omega C. So plus 2 IDC by root 2 into 1 by 3 omega C whole square. It is a root over. So sorry, a bracket on. ఓకే, సో అన్నిటిలో కామన్ గా 2 IDC/√2 1/ωc ఉందమ్మా. 1/ωc 2 IDC/√2 1/ωc హోల్ స్క్వేర్ ఉందంటే బయటకు వచ్చేసరికి స్క్వేర్ కి రూట్ కి పోద్ది కాబట్టి 2 IDC/√2 ఇంటూ 1/ωc ఉందమ్మా. సో రూట్ ఇక్కడ ఇంకేమొస్తుందమ్మా వాల్యూ 2 IDC/√2 1/ωc కామన్ తీసిస్తే ఇక్కడ ఏమొస్తుందమ్మా వాల్యూ 1. ఇక్కడ ఏమొస్తుందా
1/2
1/2 హోల్ స్క్వేర్ ప్లస్ ఇక్కడ ఏమొస్తుంది
1/9.
ఓకే, సో ఐ కెన్ రైట్ దిస్ యాజ్ IDC √2 IDC 2/√2 ఉంది కదమ్మా. √2 IDC by ωc into √1 plus 1/4 plus 1/9. Okay, so now I want to find the ripple factor value. Gamma can be written as VAC by VDC. So we have a VAC value √2 IDC by ωc into √1 plus 1/4 plus 1/9 by what is our VDC value? We got it as IDC into RL. So IDC into RL. So here I can cancel this IDC and IDC. So finally I got equation as √2 by ωc RL into √1 plus 1/4 plus 1/9. Okay, ఎవరైనా ఫైన్ చేయనమ్మా √2 into √1 plus 1/4 plus 1/9 వాల్యూ. √2 into 1 plus 1/4 plus 1/9 వాల్యూ ఫైన్ చేయనమ్మా ఎవరైనా.
Sir, 1.64.
Yes, 1.64. The value is a 1.64 by ωc into RL. So it is a ripple factor value of a rectifier with capacitor filter.